All right, so we're going to use SOHCAHTOA to just solve some application problems. These should feel kind of familiar from geometry because you've done this before. So here's my fantastic picture of this. To calculate the height of a building, Joel walked 200 feet from the base and used an inclinometer, it's hard to say, to measure the angle from his eye to the top of the building. It was 25 degrees. If his eye level is at 6 feet, how tall is the building? All right, so he walks away from this building. So this distance here is that 200 feet. And then he measures the angle to the top of the building here. Let me draw some of those in. So this is 200 feet. And then he measures this angle. It was 25 degrees. And he is very curious as to how tall this building is. Now, I'm going to call this X here. So we see this delightful triangle that I've drawn. And I think we have enough information to solve this, to find out what X is. So from this angle, X is the opposite side. Over here we have the hypotenuse. We don't know what that is. 200 is the adjacent side. So the trig function that we have that has opposite and adjacent, so think about your SOHCAHTOA. Opposite and adjacent is tangent. So we're going to be working with tangent. So the tangent of 25 degrees is opposite over adjacent, which is x over 200. We want to solve this for x, so we're going to multiply both sides by 200. I'll make those 200s cancel. And then we just need to put this into the calculator. You want to make sure you're in degree mode, which you probably are. When you look at your calculator, when it's turned on, there should be some little letters down at the bottom. It should say DEG, which means degree mode. I'm sure your calculator already says that. But if you get the wrong answer, it's because you're not in degree mode. So anyway, this turns out to be about 93 feet. Now, that is not the answer. That's how long X is. Remember, he was measuring from his eye, and his eye was 6 feet up. So we have to add 6 to this answer. The building is actually 99 feet. All right, let's check out another example problem. A golfer is standing at the tee looking up to the green on a hill. The tee is 36 yards lower than the green, and the angle of elevation is 12 degrees. Find the distance from the tee to the hole. Okay, so I'm just going to use dots here. Okay, this is the golfer, and he's looking up to the green, and I will use straight lines for this. Okay, so it looks something like that. Just pretend that's a right triangle. They all meet up. The tee is 36 yards lower, so this is 36. The angle of elevation is 12 degrees. Find the distance from the tee to the hole. I think this is the distance they want. All right, so from this angle, from this 12-degree angle, 36 is the opposite side, and x is the hypotenuse. So again, we want to think about SOHCAHTOA. And which one is opposite and hypotenuse? Well, that's clearly sine. So we'll say that the sine of 12 degrees is opposite over hypotenuse. And we want to solve this for x. So I'm going to start by multiplying both sides by x. I'll make those cancel. So I have x sine of 12 equals 36. And then we're going to divide both sides by the sine of 12. So then in your calculator, you just do 36 divided by the sine of 12, and we get 173 yards. I do not golf. Does that seem like a reasonable length? Maybe? Nathan will have to tell us. I don't know. Okay, a ramp for unloading a moving truck has an angle of elevation of 32 degrees. If the top of the ramp is 4 feet above the ground, estimate the length of the ramp. All right, let's try that one. So we have a ramp. Apparently it's going from the ground. So it looks like this. Angle of elevation So that's the angle from the ground. That's 32 degrees. The top of the ramp is 4 feet above the ground. Estimate the length of the ramp. So it looks like that. Okay. Again, this is another opposite and hypotenuse. So it looks like we're going to use sine. This looks pretty much identical to the last problem we did, just different numbers. So the sine of 32 is 4 over x. So we'll multiply both sides by x. And then divide by the sine of 32. So 7.5. 7.5 is what my calculator says. Feet. All right, the hill of a roller coaster has an angle of descent or angle of depression of 60 degrees, and its vertical drop is 195 feet. Estimate the length of the hill. Okay, so we are starting at the top of the roller coaster and going down. Now, clearly roller coasters don't go straight down, but since we're talking about triangles, that's about the best we can do. Okay, so we're going to, we know that it has a vertical drop of 195 feet. That's this. And we're just going to finish out this triangle. So it looks like this. All right. So vertical drop is 195 feet. We want to know the length of the hill. Now, angle of descent, angle of depression. Angle of depression, so if you're sitting up here at the top of the roller coaster, angle of depression is always measured from the horizon. So if you're here in the roller coaster car looking out, the angle of depression is this angle going down. That's where the 60-degree angle is. Now, that angle is not in the right triangle that we drew, which is somewhat problematic. But if you remember from geometry, alternate interior angles, if this is 60 degrees, this is also 60 degrees. Okay, so we need to make sure we put that angle in the correct spot. Okay, so now we're in the triangle that we need. From the 60-degree angle, 195 is opposite, and x is the hypotenuse. So again, using SOHCAHTOA, it looks like we'll need sine. The sine of 60 is opposite over hypotenuse. To solve for x, we're going to multiply both sides by x. And then divide by the sine of 60. Use our calculator for that. And we get the length of the hill as about 225 feet. All right, one other thing that you talked about in geometry is something called the inverse sine. It looks like sine to the -1, but that's not what it is. The way we read it is inverse sine. We use inverse sine when we want to find an angle. Okay, so if we have an equation that looks like this, the sine of a equals x, and if we know this x, we can use inverse sine to find it. You already did this in geometry, so I don't want you to get hung up on this, but we have inverse cosine and inverse tangent. On your calculator, those are above the sine, cosine, and tangent buttons. I'm sure you've used them and seen them. All right, so a 12-foot ramp has a vertical rise of 3 feet. What is the angle of elevation? So we have a ramp, it goes up 3 feet, so it looks something like that. Pretend those all connect. The ramp is 12 feet. It's going up vertically of 3, and they want us to find that angle. I'm going to call it angle A. So we're going to start the same way. 3 is the opposite side. 12 is clearly the hypotenuse. So thinking about SOHCAHTOA, opposite and hypotenuse is sine. Seem to be using sine a lot. That's not always going to happen. It just happened today. So the sine of our angle A, we don't know what A is 3 over 12. Okay, so now we want to find the angle. So we're trying to solve for A. So the way we do this is we take the inverse sine of both sides. Sine and inverse sine cancel each other out. So we get A is the inverse sine of 3/12. So you're going to do that in your calculator. Inverse sine of 3/12. And your calculator is going to tell you it is a 14.5 degree angle. So that is our right triangle trig. Like I said, hopefully most of it's review from geometry. And if you have any questions on the notes, make sure you post them onto Flipgrid.